Hi friends, I'll just try to explain a topic called as number systems here. Number systems. This is our number line. Let me just write down some numbers here. Here it is 0, here it is 1, then 2, 3, 4, and so on. And here it is -1, -2, -3, and so on. I'll just note down some definitions here just to give you clarity about all those numbers here. There's a term called as natural numbers. Now what are natural numbers? All these numbers, these positive numbers 1, 2, 3, 4, 5, 6, and so on, starting from 1 and then increasing all these numbers, then 1, 2, 3, 4, 5, 6, all these numbers are collectively called as the natural numbers. Each number, any number, if I just take out from this list, that is called as a natural number, and this list is sometimes denoted as capital N. Capital N means that is a list containing all the natural numbers. Then we have another definition or another term which is called as whole number. Now what are the whole numbers? If we just add 0 to the natural numbers, then that list is no longer called as a natural number, but that list then is called as a whole number list. So whole numbers contains 0, 1, 2, 3, 4, and so on. These all are collectively called as the whole numbers. Now you may say that 1 is a natural number as well as 1 is also a whole number. That is correct. There is another term called as integers. Now if I add all these negative numbers to the list of these whole numbers, then that list becomes a list of integers. So 0, 1, 2, 3, and so on, and here -1, -2, and so on. So all these numbers are collectively called as the integers. So 1 is an integer also, it is a whole number also, and it is a natural number also. 0 is an integer as well as it is a whole number. It is not a natural number. 4 is a natural number also, it is a whole number also, and of course it is an integer also. -1, it is an integer, but it is not whole number, and it is also not a natural number. And this list of whole numbers is sometimes denoted as capital W, and this list of integers is sometimes denoted as capital Z or capital I. Now you can see there is a gap between 0 and 1. What do I mean by the gap? Means if I just mark a point anywhere in between 0 and 1 here, we'll get a number after this. There is a number which is denoted by this point. There are many numbers that can be denoted by many infinite points between 0 and 1. I have not given any name to those numbers right now, but yes, of course there are numbers between 0 and 1. Similarly, there are numbers between 1 and 2 also, there are numbers between 2 and 3 also, and so on. So there are many more numbers which we haven't discussed right now. So we'll discuss those numbers which are included between 0 and 1, between 1 and 2, and between -2 and -1, which are other than these natural, whole, and integer numbers. I'll just write a term known as rational number. Now rational numbers are the numbers which can be written in the form of P upon Q. Here P and Q, they both are integers, and also Q should not be equal to 0. 0 is an integer, P and Q should be integer, but Q should not be equal to 0. Other than 0, Q can be any integer. So if any number can be written in the form of p by q, where q and p are of course integers and q should not be 0, then that number is called as a rational number. For example, 1. It is a natural number, it is a whole number, it is an integer also, and it is a rational number also. Why? Because 1 can be written as 1 by 1. Now both are integers. This is p, this is q, and q is not equal to 0. Yes, then it is a natural number. It is a rational number. Of course, 1 is a natural number too. So 1 is a natural number, 1 is a whole number, 1 is an integer, and 1 is also a rational number. Another example, let's say 2. I can write 2 as 2 by 1. Now 2 is a natural number, 2 is a whole number, 2 is also an integer, and also I can write 2 as 2 by 1. I'm just writing 2 as in the form of p by q. Here p is 2 and q is 1. So both are integers and q is not equal to 0. So yes, it is a rational number also. Another example, let us take a number as 4. Again, I can write 4 as 4 by 1. So yes, 4 is an integer, q becomes here 1, and this is also an integer. Then this ratio, again this ratio is 4, and this has to be a rational number. Now all those numbers that I have written here, these are rational numbers. But can you imagine some other rational number that I have not mentioned here? Yes, there are many more rational numbers that I have not mentioned on this number line right now. I'll give you an example. For example, 7 upon 2. I haven't mentioned this number on the number line, but yes, this is a rational number because this is in the form of p upon q, and q here is not equal to 0, and both p and q here are integers. So yes, this is a rational number. This is not a natural number, this is not a whole number, this is not an integer, but it is a rational number. There are many such numbers that I can write. For example, 15 by 2. So this is also of the form p by q. P and q are integers, q is not equal to 0, so it is a rational number. I'll give a simple example. Suppose this is a number line, this is 0, this is 1, and so on. This is minus 1, minus 2, and so on. If I write a number 1 upon 2, now this is a number which lies exactly between 0 and 1. This midpoint of 0 and 1. This number is actually 1 by 2. Again, this is of the form of p by q. Q is not equal to 0. So this is a rational number. If I just locate a midpoint of 1 and 2, midpoint between 1 and 2, then that number will be 1 plus 2 by 2. I'll just explain later on how this trick comes out to be 1 plus 2 by 2. I'm just simply adding these two numbers and then dividing by 2. So this comes out to be 3 by 2. So this midpoint of 1 and 2 is actually a number 3 by 2. So there are many more rational numbers that I didn't write in the starting. But yes, all these numbers, 7 by 2, 15 by 2, 1 by 2, and many more. Let's say 1 by 3, 1 by 4, 7 by 6. These all are rational numbers because they fulfill the condition of a number being a rational number. P and q are integers and q here is not equal to 0. Now can you imagine any number other than all these numbers that I have just written down, and that can be separated from the category of rational number? I'll just make my statement again. All the numbers that I have written on the number line initially, like this, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, these are rational numbers. And then we saw there is a number between 1 and 2, 1 by 2. There is a number between 2 and 3, and that number can be written as 2 plus 3 by 2, that is 5 by 2. Sorry, this is not 1 by 2. The number between 1 and 2 will be 1 plus 2 by 2, that is 3 by 2, and here between 0 and 1 it will be 1 by 2. So all these numbers are rational numbers, 1 by 2, 3 by 2, 5 by 2, and of course these also. Are there any other numbers left that we haven't included here? I'm just saying that all these numbers are rational numbers, but Can there be any other number which I haven't just written here? Yes, there are other types of numbers, and those are called as irrational numbers, and those numbers cannot be written in the form of p by q. We have just seen the definition of a rational number is if any number can be written in the form of p by q, where p and q are integers, then yes, then that is a rational number, and of course q not being 0. But there are many numbers, and there are infinitely many numbers, those cannot be written in the form of p by q, and those numbers are not included in the category of rational numbers, and those are called as irrational numbers. I'll just give you an example of that. There is a number root 2. Now the square root of 2 is not written in the form of p by q. It cannot be written in the form of p by q, where p and q are integers. So this is not a rational number. So such numbers which are not rational number, those are called as irrational numbers. So I'll just write this thing again. Real numbers can be broadly classified into two categories: rational numbers and irrational numbers. Then we have seen what are natural numbers, then we have seen what are whole numbers, and we have seen what are integers. All these are rational numbers only, and all the numbers other than these numbers and are called as irrational number. Other than these and these numbers are called as irrational numbers. We have also seen that 1 by 2 is a number which is not a natural number, which is not a whole number, which is not an integer, but yes, it is a rational number. So all those numbers which cannot be written in the form of p by q are included in this category known as the irrational number. So I'll just ask you another example. What is root 3? Is it a rational number? Is it an irrational number? Is it a natural number? Is it a whole number? Is it an integer? What it is? It's not a natural number, it's not a whole number, it's not an integer, it is not even a rational number, because root 3 cannot be written as in the form of p by q. So actually it is an irrational number. Pi is an irrational number. So there are infinite natural numbers, there are infinite whole numbers, there are infinite integers, there are infinite rational numbers, and yes, there are infinite irrational numbers. Root 17, root 13, root 11, all these are irrational numbers. Root 29, root 31, all these are irrational numbers.